One of the things that makes distance time graphs very confusing are the scales that are used on the graphs that you draw. So what I always do is, before even thinking about what's going on in the question, actually getting my head around what the scales are on the graph. So we'll do that here. We'll start with the vertical axis, which is the distance axis, and we can see here that we're going from 0 to 10 in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20 equal jumps. So in order to go from 0 to 10 in 20 little steps, that means each little step is going to be half a mile in this case. So I know that each of these is half a mile. Okay, so each little unit going that way is 0.5, 1, 1.5, and so on and so forth. So I've worked out that 0.5s. Going this way now, it's time. Okay, and you can see that that's 11 o'clock, 12 o'clock, 1 o'clock, and these tick marks 1, 2, 3. There are 3 of the big tick marks in that gap. So if we're talking time, each one of those is going to be a 20-minute spell. So if that's 11 o'clock, that's going to be 11:20. This is going to be 11:40, and so on. And then within there, I'm going to go from 11 o'clock to 11:20 in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little jumps. So I'm going 20 minutes in 10 jumps. So each of these squares is worth 2 minutes. Okay, so each of these little squares is 2 minutes. Half a mile each square up, 2 minutes each square that way. Once I've done that, once I'm happy that that is what the scale is going to be, then I actually look at the question. So what we have are 3 towns: Aber, Tipton and Moncton. They're on a bus route. Tipton is 20 miles from Aber, and Moncton is a further 40 miles from Tipton. And these are shown on the graph as Aber being 0. Then if you travel 20 miles further on, you come to Tipton. And then because the scale starts at 0, 40 miles further on from there takes you to Moncton, which is in fact 60 miles from Aber. Gareth catches a bus from Aber to go to Tipton. The distance time graph opposite represents the journey of Gareth's bus. At what time did Gareth's bus leave Aber? So Aber is here, and that is when Gareth is going to be leaving, and we've worked out the scale already. It's going to be 11:40. So Gareth's bus leaves at 11:40. At what speed in miles per hour did the bus travel from Aber to Tipton? Well, it starts there, and the easiest way to work out its speed is to find out how far it's travelled in an hour. So an hour from there would be 20 minutes, 40 minutes, 60 minutes. That would be an hour, but my graph doesn't pass that line. So if we were to keep it going, that's how far it would travel in an hour. That point there is 20, 40, 60 minutes on from the starting point. So if I worked out if it was to carry on for an hour, that's how far it would travel. That would give me its speed in miles per hour. So just putting that onto my graph and reading that off, I can see that that's in fact 25 miles. So it's going to be 25 miles per hour. Explain fully what the part BC represents. Well, BC is a flat line. So what that means is time is moving on, but the distance isn't. So if time is moving and the distance isn't, the bus is stationary. So BC, for the time BC, or for the part of the graph BC, the bus is stationary at Tipton. So Gareth is at Tipton. Okay, Gareth's friend Roy lives in Moncton. Roy starts out at 11 o'clock to meet Gareth's bus at Tipton. He travels at the speed of 30 miles an hour. On the same graph paper, draw a distance time graph of Roy's journey. So Roy starts from here at Moncton and he leaves at 11 o'clock. Now if he travels 30 miles an hour, it means that in an hour's time at 12 o'clock, so if I put my ruler at 12 o'clock, graph paper is horrible, we know he's going to be 30 miles away. Well, 30 miles is 10, 20, 30, which means in an hour he has travelled that far. And because the speed is constant, that's the distance that he is going to travel. So we can keep that line going, and we'll see that he reaches Tipton, which is there, before his friend does, before Gareth does. So on the same graph paper, draw a distance time graph of Roy's journey. So he leaves Moncton there, he's travelling at 30 miles an hour, so at 12 o'clock he would have travelled 30 miles, but he keeps going, so he gets to Tipton there. Explain whether or not Roy gets to Tipton in time. Yes, he does. He gets there before Gareth. Roy stays in Tipton until 1 o'clock and then returns home by 2. So he stays in Tipton until 1 o'clock, which is there. So he's not moving from that point. But then he gets back to Moncton by 2. So at 2 o'clock, which is there, he's going to be back in Moncton. So if I just mark that on the graph there, that's going to be the final part of his journey. Okay, so he arrives at Tipton there, he stays until 1 o'clock, which is that point there, and he gets back to Moncton by 2. So that point corresponds with that particular bit of information, and that will give you the distance time graph that you need to produce. Okay, question 2. Same thing again. I'm going to start off working out the units on my graph. Now this particular graph, you've got to turn the page around in order to read it. The distance is always vertical. Okay, so in this particular question, we're going from 0 to 10 in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's straightforward. Each little square is 1 mile. That way. And going this way, halfway is going to be, what do we got there? Halfway is there, so that's 11:30. So I'm going 30 minutes in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15 squares for 30 minutes. So each little square is 2 minutes. Okay, so each little square that way is 2 minutes. So this way is 1 mile, that way is 2 minutes. Okay, so let's take a look at what we're dealing with. The graph opposite shows Gary's journey by car from his home to his services area, where he stops for a while before returning home. How far is the services area from Gary's home? Well, the service area is where he stops. So we know from the previous question that if he's not moving, the graph is going to be flat. So that area or that part of the graph is going to be where he's at the services. So if we read that off my scale, you can see that that's going to be 51, 2, 3, 4, 5, 6, 7, 57 miles from Gary's home. How long did Gary stop at the services area? So we need now to find out this period of time where the graph is flat. So it starts there and it stops there. So that's the amount of time, and we know that each one of those squares is 2 minutes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 little squares. 23 lots of 2 minutes is 46 minutes. Okay, so that's 23 squares that we've got there, each being 2 minutes in length. So that's going to be 46 minutes. And then finally, use Gary's graph to find the average speed for his journey home. So average speed is the distance travelled divided by the time taken. Distance divided by time is speed. Well, for his journey home, we know the distance is in fact 57 miles. So av speed is distance divided by time. The distance is 57 and the time, and we want it in miles per hour, so we need to turn the time into hours, is going to be, and again there's a little square counting exercise now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 lots of two minutes. So that's going to be 72 minutes. 72 minutes is 1 hour 12 minutes, which you've then got to turn into a decimal of a fraction, and 12 minutes is 12 out of 60 as a fraction in terms of an hour. There's 60 minutes an hour, so you can do 12 divided by 60, which is 0.2. So 72 minutes is 1 hour 12 minutes, which is 1.2 hours. So you have to do 57 divided by 1.2, which is 47.5 miles per hour is his speed. So these are quite tricky questions because you've got a lot to deal with there. You cannot put that as 1 hour 12 being 1.12 because that's out of 60 minutes, not out of 100 for decimals. Question 3, same again. These graphs are copied horribly. Going this way, we've got the distance, and we're going from 0 up to 10 in 20 little squares. So each little square that way is going to be half a mile. And going in this direction, we've got 1 hour 60 minutes in 20. So each little square there is going to be 3 minutes. 3 lots of 20 is 60 minutes. Right, let's take a look at the context that we're working with here. So we've got Jackie living in Whitchurch, which is represented at the bottom of the graph. Brian living in Bishopston, which is there. Which is 50 miles from Whitchurch. One day they decide to meet at Baglan, which is somewhere in between. After meeting, they each return home. The graphs on the next page show part of their journeys. How far is Baglan from Bishopston? So Baglan is there, Bishopston is there. That's 10 miles, 20 miles, and 1, 2, 3, 4 little squares, which is another 2 miles. So it's going to be 22 miles. How long has Jackie been waiting at Baglan when Brian arrives? So here's Jackie travelling from Whitchurch. Her flat graph there is where she's been waiting. So she's been waiting for 1, 2, 3, 4, 5 squares. 5 lots of 3 minutes is 15 minutes. Without calculating any speeds, explain how you can tell whether or not Jackie had a higher average speed on her way to Baglan than Brian did on his way home from Baglan. So this was Jackie travelling to Baglan, and this is Brian travelling away. And the way that you can tell is by the steepness of the graph. The steeper the graph, that means the further that person has travelled in a period of time. So the steeper the graph, the faster the speed. And you can see here that this part of the graph is a steeper line than this part of the graph. So Jackie travelled the faster. So Jackie had higher speed. Explain how you can tell. So just writing that wouldn't get you the mark. You need to say, because her line is steeper. That will get you the mark. Jackie leaves her home at the same time as Brian. She travels home at an average speed of 25 miles per hour. So they leave at that point, and an hour later she will be 25 miles further down the graph. So if we can find that point, then we can draw the straight line and continue it for the rest of the journey. So again, with this graph paper, it's not a really easy thing to do. On your exam paper, it'll be larger and it'll be much easier to work out. Anyway, let's have a go. So let's do it off. So that point there is where she's leaving. So we need an hour further on from there, which will take us halfway between there. So that's the line, and we need to be 25 miles down from there at that time. So if I just line my ruler up with that there, so 25 miles down, that we said was what's that going to be? That's going to be 28. So we're looking for 3 miles this way, which is going to be 6 squares. 1, 2, 3, 4, 5, 6. So that point there is an hour further on, and it's 25 miles from there. So if we now join those 2 points up, that's where she's leaving. That's an hour later, but she's going to keep going until she gets home. So that's that part of the journey, and that's all you need to do for that. Question 4. This is really copied badly. That's a much better graph on the exam paper. Let's see if we can work with it. We may not even be able to work with this one. The distance time graph shows 140 kilometers journey from Meadow Green to Tarn Close. So there's Meadow Green, there's Tarn Close. What is the distance travelled between 1300 and 1430. Well, 1300 we are there, so we can read that off the graph, and 1430 is there, and we're going to struggle here to read that off the graph. The distance travelled, this actually works out on the proper thing to be steps of 2 kilometers, so that's going to be 64 kilometers, and that's going to be 118 kilometers, so it's going to be the difference between 118 and 64. So that's going to be 54 kilometers. The average speed for that part of the journey, well, as I mentioned earlier, average speed is distance divided by time. So speed is going to be distance divided by time. The distance is 54. The time between 1 o'clock and 2:30 is an hour and a half, which is a decimal is 1.5. So we do 54 divided by 1.5, 36 miles per hour, kilometers per hour. Explain how can you tell from the graph that it took less time to travel the first 70 kilometers of the journey than it took to travel the final 70 kilometers. Well, again, you can see here that the first 70 the graph is pretty steep. In the last part of the journey the graph is much less steep, so it's going to take a lot longer to travel that distance. So we can tell because the curve is much steeper for the first part of the journey, which means it is traveling faster. Okay, because the curve is much steeper for the first part of the journey, which means it's traveling faster. And then the final question that I found on distance time graphs describes the journey and gives us a choice of 4 graphs, and we have to pick the right one. So Sammy left home and drove to work. Along the way she had a stop at the school crossing. She then travelled at an increased speed until she arrived at work. Which graph best shows her journey? So what we're looking for is, first of all, a straight line, which, because she stops, we've already seen with the other questions, means it's going to flatten out, which means it's either C or B. But then it says she speeds up after the stop, which means the line after the stop is steeper than it is before the stop. So the graph that we're looking for is graph B, and we need to give a full explanation. Okay, so it's graph B because the flat line shows where she stopped, and then the line gets steeper than it was before she stopped, which means she was then traveling faster. and that's your full explanation. You're talking about the stop and then comparing the steepness of the lines before and after the stop. So sometimes a distance time graph can be quite straightforward, other times it can be quite difficult to do, but really the first thing you need to do is to work out what the scales are, what each little square vertically represents for distance and what each little square horizontally represents for time.